All right, so today is going to be mostly in breakout rooms where you can start working on some data analysis. But before that, I should mention that assignment number, I think it's 7, the intro has been graded and feedback has been uploaded to eCampus. I actually did it on Monday, but I just want to let people know. Come see me, please, if you have any questions about the feedback left. For some people, I said, specifically, hey, come see me. I think we'll be able to, I'll be able to tell you a lot more in person rather than typing it all out. Just as a reminder, if you submit it if you address the comments that I left and you clean up your intro and you have it submitted by next Thursday, you can get an extra 3 points. Depending on, if you actually address the comments. So if you want any extra points, go ahead and do that by next Thursday. Yeah, see me during office hours if you have any questions, and I'll be able to better help you structure your intro. For assignment number 11, this is the factorial experimental design homework assignment. Because in class with Dr. Tenenholtz, you couldn't get through all this material, it's now going to be due Monday at midnight. Let's see, very briefly, it's a relatively short homework assignment. Shouldn't take you that long, hopefully. There's just two hypothetical results. And you're going to have to identify any main effects and any interactions. This is just simple yes or no. Is there a main effect? Is there interaction with this specific variable? Yes or no. And then at least for the first problem, you're going to have to highlight in the paragraph where you found an information. So, first off, you're going to identify the main effects and interactions, but really focus on how do you know that information? Like, how do you know if there is an interaction, or how do you know if there's a main effect? That's really what the first question is addressing. From a written paragraph, I should say, because the second hypothetical, the second question is going to ask you to graph out the data, and we're going to get into that a little bit today. It's relatively easy, but I'll walk through it a little bit later. And then you're going to have to identify from that graph if there's any interaction or main effects, and then answer some of the questions that go along with that, like explaining how do you know if there's an interaction or not. Like I said, shouldn't take you that long. It's just 2 main questions, which is a couple sub questions. Shouldn't take you that long. But if you have any questions about what you're doing, please see me during office hours and I'll be able to help. Does anyone have any questions about the intro assignment or any questions about assignment number 11?
Yeah, are we submitting the intro, like the updated introduction, through like a Dropbox and eCampus, or do we email it to you?
I don't think there's currently one set up on eCampus. Go ahead and just email it to me. Email it to me by Thursday and by next Thursday, and I'll do it. Okay. So the main goal for today should be analyzing your data, or beginning to analyze your data. Step 1, we've already done. We've already cleaned. This is what was done over the group meetings. We all should have kept track of how many participants we ended up deleting because of, for whatever reason. I believe there was one group where I did not do that with. So I'm going to jump in and out of breakout rooms, but I believe there's one group where I didn't focus on. It might be group 1 where I didn't keep track of how many people we cut out. If that is the case for your group, we can talk, and then I can tell you how many people we deleted. Anyway, so we've already cleaned up the data. That's all done. So now we can start getting into describing some of the data with descriptive statistics. So can someone tell me what type of stats that we're going to need for descriptive statistics? When I say descriptive statistics, what does that mean?
Like the mean age.
Yeah. So mean and standard deviation of something like age. Can someone tell me another descriptive statistic? Let's say for something like gender or race.
The standard deviation.
So we wouldn't want the standard deviation for something like race, right? What would
Okay.
standard deviation wouldn't tell us anything. What about, so specifically for race or gender, what would we want to know?
Would you use like percentages to see how frequent they are?
Yep, perfect. So you would just want to see, what percentage of your sample was male, or female? What percentage of your sample was white? It's probably relatively high for all of you, but that's okay. That's the way research goes. Anyway, so you can see here, we type, or it's typed out, how you find this information for nominal variables or variables like race and gender, or categorical variables rather. In SPSS, you do analyze descriptive statistics frequencies, and I'll output a couple of tables, and it'll tell you percentages that, each category within, gender, what percentage, of your sample is made up by that. For quantitative, so, things like age, or your outcome variables, you have things like you go to analyze descriptive statistics descriptives, or you can go to explore, which tells you a little bit more. So if you remember back to 203, one of the things that you reported on your variable was, on one of your variables was skewness. So that might be something that you want to report here as well. Look at the skew of your outcome variable, or if you did a manipulation check, look at the skew on your manipulation check. If you're if you want to check to see if, I don't know, your manipulation stressed people out. I know a couple groups, one or two groups had asked, something along the lines of, did you feel stressed out after doing this, or something, similar. You would probably want you would hope that your data is skewed, or your manipulation check is skewed in a way that people ended up reporting, or a majority of people ended up reporting being stressed out from your manipulation. If, for example, if you asked a manipulation check, are you stressed out after doing these math problems? And a majority of people said no, on a scale of 0 to 5, with 5 being the most stressed and 0 being not stressed at all, a majority of people said 0 or 1 or maybe even 2. And so, it comes out as being skewed in that direction. Then you might be able to say, oh, well, maybe this is why we found insignificant findings, because our manipulation check really didn't elicit stress, and then how would you show that? Well, our data was more skewed, to the left. So that can be found, this is all descriptive data. Remember, this is not, correlations or t-tests. You're not comparing two variables. You're just looking at some descriptive information about one specific variable. But you want to do it for, say, all your demographic variables. So that's one thing you could be doing, or should be doing. Next up, you're going to want to graph your data. So you need to think about what visual display will most clearly show your results. Is that going to be a bar graph? Is that going to be a line graph? This is up to you to think about your data. And now I don't want to see, when I say graph your data, what we don't want to see is a bar chart or like a pie chart or something of males and females. It just shows you how many males and females there are in your study. We don't want to see that. That's not really that useful. Rather, what data you should be graphing is, well, let's compare, you run your t-test, right? And so what does a t-test tell you? Well, it compares two groups on some outcome. Well, that would be perfect to graph. Think about a bar graph where you can have you have two bars. It's broken up by condition. So one condition is one bar, the other condition is the other bar, and your x-axis is your outcome. So right there, you can have a really easy bar graph depicting your results. For groups who did pre-test, post-test, and you were looking at change scores, which I believe a lot of groups are, I'll help you individually with your graphs, because you may want to do a factorial graph, and I'll explain why in breakout rooms, but we can get to that when I jump around. For graphing, it says see graphing under other resources, and I want to pull up the Word document. So can everyone see this Word document that I pulled up? Okay. So what this is a step-by-step for how to do graphs in Excel. But more importantly, and I think more usefully, you can just edit these graphs with a couple clicks of a button, so that way you don't have to make these graphs by yourself. And here's what I mean by this. So let's say you want to use this type of graph. You say, okay, I want to do a, let me just get rid of this one. I want to do a bar graph, right? With a simple bar graph that looks at condition 1 and condition 2 when some outcome. Well, we have this template here for you, and it's very easy to edit. So, and now on the instructions, above the, on instructions on the first page, it tells you exactly how to do this, and it may differ for Word, for Mac and PC, but the stuff should relatively be the same. But what you can do is, at least on PC, right-click, edit data, and it'll open up into an Excel spreadsheet. And this is really useful because now we can change all of this just by putting in two means. We can change this bar graph and have it represent our data. So real fast, someone give me an independent variable that has two levels. It could be one you use for your own experiment, or it could be anything else that you can think of.
Emotions.
All right, what about emotions?
Happy or sad?
And so explain happy and sad. Are you doing some, what's the manipulation?
Like participants will feel sad when they watch like the sad video condition rather than.
Okay, so what we want here is, and I'm going to go off of this emotional condition here, but think about your independent variable, right? What is the independent variable in your in all of your studies? It is something that you manipulated. So there's two groups, right? It may be a music condition and a no music condition. It may be a let's think back to the studies that we did like in the first week of class or the second week of class. It was one condition might be Golden Globe dresses, and the other condition is prom dresses. So remember, your IV is broken into two levels. So let's say that we had a happy condition where participants watched a happy video, and sad conditions, and a sad condition where participants watched a sad video. So right here in Excel, by doing that edit data, right-click, edit data, we have, I typed in happy and sad in here, and it changed to happy and sad. All right, I'm going to get rid of the standard errors because we don't need them. All right, so what are we going to be measuring? So we have a happy dog video and a sad dog video. What type, someone else tell me, what should our outcome be? Anybody?
Can you repeat the question?
So what should we measure? What should the outcome be? In this experiment we have a happy dog video and a sad dog video. What is our dependent variable? What should we measure?
Would it be mood after watching the videos?
It can be anything. I'm just asking people to design an experiment. It doesn't, just whatever you want.
Oh, well, mood could be a dependent variable.
Sure, mood. That'd be a very simple and easy one, mood. And let's say, let's just be more specific, and let's just say positive mood, where the low end is, a low positive mood, and if someone scores really high, it's a really high positive mood. All right. So let's say you run your independent samples t-test and you find the means of your two groups, right? Remember, when you run a t-test, it tells you the means of both groups in the first box that it outputs on SPSS. So let's say our scale was 1 to 5, and we're looking at, and we averaged the score. So participants in the happy condition had a mean of 1.25, and participants in the sad condition had a mean of 3. Well, okay, that doesn't logically make sense, but it'll be fine. So participants in a happy condition 1.25, participants in a sad condition had an average of 3. Okay, so we can exit out of this, and we can see that our data has been changed, right? Well, this scaling over here is really not that useful, right? On a scale of 1 to 5, we don't need our x-axis to go to 0 to 600. So let's just double click on this. And once again, there's instructions on how to do this, but I just have to double click, and let's change it to 0 to 5. Right? Our minimum and our minimum is 0, and our maximum is 5. And our major units, which is how it's broken up over here. Let's see, is a 1 okay? 1 looks okay. How about a 0.5? Yeah, 0.5 is all right. Maybe a 1 is okay too. We'll just keep a 0.5 because whatever. Anyways, so we have, let's relabel this as condition. All right, okay. Anyways, so you can label this as whatever you want. And now, just with a couple clicks of a button, you now have a graph that you can copy. You can copy and paste it onto your own Word document, whenever you, for your final paper. So you just, copy and paste it. Anyways, so use this Word document so you don't have to start, trying to figure out how to create Word graphs, from scratch. We have all the templates that you need. I also recommend you do this for your homework assignment. So in your homework assignment, what you're going to have to do is graph out the data. Well, we already have and this is the type of graph that you're going to need for factorial designs. So we already have this set up for you. So all you have to do is edit the data, and we give you the data. We give you the means of each group. Edit the data in this Word document, and then paste it onto your homework assignment. So don't try to create a graph out of scratch. It says you can do it in SPSS or Excel, but Excel is recommended. Highly recommend you do it in Excel because it's already set up for you on this graphing in Excel worksheet or Word document found on eCampus. A little bit ago, I briefly mentioned that people who have pre-test, post-test designs, even if you're using a change score. So if you're using a change score for your outcome, and I know a lot of groups are, whenever you're making a graph, one of the things I would suggest you use is this, is this graph. Alternatively, you could use a bar graph like this, where you just compare your change score in each groups. However, for reasons that I'll get into in individual groups, if they have questions, I suggest using this graph. So you can look at pre-test and post-test and have both your conditions. Anyways, I wanted to show you this Word document to show you that it exists and that you really should use it because it will make your life a lot easier. All right, so that's graphing your data. Step number 4, if you have time, is the inferential statistics. Now, we will have time next week to work on this. We will have time next week to work on this. So if you don't get to it this week, that is okay. But think about what type of inferential statistics that you're going to want to do. So most of you, if not all of you, probably have a IV that only has 2 levels. So what are you going to use? A t-test. Now, whether that's a one samples t-test or an independent samples t-test, that's for you to determine if you're doing a between or within subjects design. But I don't believe anyone is doing an ANOVA or has 3+ levels of an IV. So I believe all of you are going to be sticking the t-tests. Some of the things that but once again, if you don't get to that this week in your breakout rooms, it's perfectly fine. You'll have more time next week to work on doing the actual inferential statistics. But throughout all of this, whenever you're doing the descriptives and whenever you're doing your graphing and the inferential statistics, think about the interpretation. What is it really showing? What is it really saying? And think about any other statistics that you might want to run. What about the manipulation check? If you have a manipulation check question, You know, how are you going to use it? Think about some groups have multiple dependent variables. So you have your main one, but I said that there's other things that you could run, right? Some groups want to look at, or some groups assess ethnicity or race, or most of you assessed gender. So what happens if you want to know, you know, oh, for our experimental condition, does gender matter at all? Well, if you're interested in these type of questions, or does race matter at all? If you're interested in these questions, talk to me, you know, this week and next week, and I can show you how to do that. It's within SPSS, you can filter results so that way you can filter out everyone who is in quote unquote the control condition. So you just have data from the experimental condition, and then you could run an ANOVA and see if ethnicity matters. But if these are the type of questions that you're interested in, you know, you want to go past your just basic independent variable or your independent samples t-test, and you want to look at some other things, let me know and I'll be glad to help you. So I've already done a demo to move on from that. So yes, so I'm going to open up breakout rooms. You're going to go into your breakout rooms and start working on doing some descriptives for your data, doing graphing, and potentially start looking at your inferential statistics with your independent samples t-test. Does anyone have any questions about anything that I've gone over? I see someone says, I downloaded the Word document and the graphs aren't showing on it. I don't know if that is a problem with whatever computer you're having, but the graph should be there. I'm not sure if anyone else has downloaded the Word document yet and is having similar problems. I should mention that the assignment number 11 is not a group assignment, so make sure you do that on your own time. Today should be focused on starting your data for your experimental project. So I'm going to go ahead and open up